Welcome to Maven's Talk series. This session is about SRE Principle and Service Level Objective. Programmed by Digitarati, India's first IT finishing school.
Today we are going to talk about SRE. Before we begin, let me kind of give you a couple of times this word is used with a different meaning. Some of them called as site reliability engineering and some of them called as service reliability engineering. So that's one thing that, for our discussion today, we will keep it limited to service reliability engineering. And I'll explain why, we call that service reliability engineering. So look, today what we're going to do is typically focusing on what would be the reimagined approach to service management. How are we going to see, how the service management has changed over last couple of years, and we are going to then deep dive on what would service reliability engineering can be best defined, and then what are the capability building blocks of the SRE, which is what I would say would be key takeaways for the people on the call. And this session is typically focused on people at all the level. People who are technical, they would be able to get something out of it. People who are not so technical, but let's say technical visionaries, would be able to get a sense of how they can take something out of this session, right? So I'm going to take you back to the history, back in 2003, right? When Google came forward, and then kind of they envisioned the best way to handle how their systems and services can be handled. So by that time, if you look at how a system, which we today call it as an infrastructure or an application system, was being managed. So typically the systems were being managed by somebody called as system administrator, and their core job was basically to assemble the system, which would be kind of created or maybe developed by a product management team. And their focus would be more on running the systems, which essentially means that any kind of issues that are reported out, take care of that, and then resolve it. And then the bigger concern at that point of time was that people who were developers, they were keen on developing and bringing new features. But then the people who were basically from the run team, they always fear this development change, because these changes was always came up with the cost of more issues and more time, and hence there was always this deadlock. So what the run team suggested, that let's have some launch and change gates. And what it essentially it means that as and when there are new features which are being deployed into any application or any product, then they would have to go through some of those criteria for acceptance, right? And hence the evolution of launch and change gate happened back in 2003 and 2004 onwards, when Google saw this as an evolution. The bigger problem at that time was that this system administrator role was actually more like a linear role. So more applications you add, more complexities you add to the existing application, you would have to scale a team, right? If you have, let's say 100 tickets which are coming on your monthly volume, then you will have, let's say 5 people. And if at all it goes to 200, then the number has to increase to, let's say 7. As a result of it, there was a direct cost, which was killing the organizations, which means that all the direct cost of the engineers, the direct cost of the system that they're using, and so on and so forth, was always non-controllable, because you need to have a team, you need to have system in place so that the run and the change part can be managed. There was of course an indirect cost as well, reason being all those specific nuances on the system, right? For example, any ad hoc capability that you need, any ad hoc application support that you need would always be seen as an indirect cost, and hence this this whole nuance of cost getting increased was very, very high at that time. There were of course very few launches. The reason being, there was always this fear that the number of changes that you make into the system, which means number of release managements that you do into the system, the more issues that will create, and hence the launch and the change gates became exorbitantly high and complex, and hence the number of launches were really, really reduced. This created a new problem that every time when the organizations, or in particular Google, used to think about launching a new feature, then their whole question of stability always stopped them, and then it was a problem that they need to deal with. And then the last but not the least is the TTM, the time to market. So you can imagine that if there are multiple issues into the new products features being launched, and there are too many quality gates, too many parameters to be considered on, then the time that you would take to market on any new capability, any new feature into the existing product will eventually increase a lot. So these were the problems. Like, we all know that necessity is the mother of invention. And like in this case, Google then came up with a new approach, which they termed as site reliability engineering, but we, for our discussion, will consider service reliability engineering, because service reliability is what we essentially look at, right? Any kind of services, application as a service, DevOps. I mean, all these components as a service can at least give you a broader view of how you should look at. So, couple of key things that came up as a solution to the problem that these guys faced into the way they were running their IT organization was this entire culture of engineering, right? Where somebody takes a stab of what are the challenges that you see, instead of just playing a blame game, can be resolved by having an engineering mindset. Okay, let me look at the things where it is getting wrong and try to resolve it, rather than just implementing quality gates and the launch gates and make the things more complicated. The evolution of monitoring, which essentially means that your log monitoring, your events that you get generated as and when you have your systems which you set up, your infrastructure usage, if it goes down, if it goes up, then you get an alert, right? And then it was very controlled, because then you can get proactive alarm that these systems are being used, and hence a proactive measure can be taken. So in that case, eventually the stability with the launch of new feature was to a certain extent got addressed, because you can proactively set up some monitoring parameters to take care of it. The other evolution that happened is basically the whole system was actually very static, which essentially means that you would have your service level, let's say 95% and all that, and nobody would actually take up an accountability that if there are certain failures that are happening into the system, then what would be the better way to control it? And that's where this evolution of service level objective and service level indicator came in, which essentially means that I would identify what is the objective of my service level that I wanted to give, and I would also indicate it by measuring it, because what you cannot measure, you cannot really control it. And hence the SLO, SLI were really handy for the team, because that's where they were able to identify what are the intervention areas where they need to stop the launches and where they still have capacity to do more. Then, as you would imagine, a lot of times the people who are into development world, they continue to master the area of development and have very little focus and very little visibility on how a run operations work, until unless they have kind of worked into a run phase. And in the same way, the people who are into run, they have very little focus on the people who are into development. So I mean, as I explained earlier, that they were all considered to be two corners, and hence what was being thought that the team which is being formed would have to be mastered into both, right? Both into product development and also into the support part. And hence it was decided that let their focus be 50-50%, because if they are into development, then they know that how important it is to launch the feature, and if they are into support, then they know where to stop. So typically, if you have to think about it, think that this arrangement is how a development person will think about a support organization, right? So that's where this whole distribution important, so that they understand the nuances of both development and run. Now, the scalability was a problem in the system admin, because as you could imagine, that number of tickets, number of product features was linearly related to the number of resources that you need to put into the system to take care of it. So how would you control it? So the better way to kind of think about it is, how would you automate, let's say, some of those repeatable tasks where your manual intervention is very limited to the issues which are new, rather than focusing on putting people against everything that occurs, and hence would not be the best usage of your manpower. Last but not the least, the demand forecast, right? As you could imagine, right, a couple of times the whole system of admin approach was typically focused on, once the thing happened, then they probably take up some steps to remediate it. One classic example was the infrastructure available for them to use. As you would imagine, that the provisioning process of any of the infrastructure element used to take a lot of time, and hence it was making a lot of sense to see if we can eventually forecast what would be my demand 2 months down the line, so that then I can be kind of very well positioned to take care of my future demand, and hence would have all the inline technologies, inline processes to take care of it. So this is, I would say, a reimagined approach, where by bringing in the engineering mindset, monitoring, SLO, SLI, and a partial focus on both the support and development, automation, and demand forecast were the key underlying tenets that they have identified. Let's go and look a little bit more deeper on what essentially it means. Great. So as there was a Gartner research on this, and then what was identified, that there are 40 to 90% of the total system costs are incurred after the birth of the system, which essentially means you typically invest time and money, which is typically a little bit very well forecasted once the system is being developed. But once it comes into the production, because you have a very limited engineering mindset back in the days of system admin, and hence the run cost was exorbitantly high, and I would say an uncontrolled would be a right way to kind of mention it. So that was, also one of the reason why the site reliability engineering was formed. Now, if you look at what are SRE engineers, so typically, the people who were being designated as SRE had a very different job profile altogether back in those days and including today. So everybody, were one thing that was very common, irrespective of the domain and discipline that they would support, is coming up with an engineering mindset, not, delegating the task and thinking about that this is not my responsibility, somebody else has to take care of it, but rather with an engineering mindset, typically going and thinking like a problem manager, right? We typically know about this function into ITIL, where a problem manager is basically a person who is designated to identify the root cause and fix the root cause, rather than just giving a intermediate solution to the current problem. So that was one mindset that was very, very important. The second was definitely the reliability part. Now, you understand that you as an end user, an end beneficiary of a service, you don't really care whether your systems are available or not. If it is something which is available for you when you wanted to use it, and giving you the topmost features, or rather the features that you aspired for and the features for which you have bought that product or bought that service, then that's would you call it as a reliable service. And the example that we have picked up for today's discussion would very well explain that fundamental principle of why a focus on reliability is very important. Then, while you are looking into the entire spectrum of the services, then you need to look at from the entire broad portfolio, right? Which means that your applications are not just applications, but in fact your applications are having a database connected, and probably the applications can be on-prem or on cloud. And then typically it also includes the infrastructure component, which would be a combination of your network, your data center assets, and so on and so forth. So typical focus on the engineering principles, the focus on reliability, and a broad focus on looking at what would be the areas that you need to think through, is what was defined, uh, that it would be the mindset of a service reliability engineering. Let's go a little bit more deeper to understand what would be the typical focus areas of a service reliability engineer. So one, as I said, that reliability, by definition, the reliability is not from what you as a support or a developer of an IT services is defined as a service which is reliable. It is basically the users, right? Imagine that you're using an application and the back end of the application is being supported by an application database infrastructure, and the components are available, but you are not getting that feature, whatever you have signed that application for. Would you continue to use that application, right? Or would you continue to use that service? So if we have that as an answer, yes, that means the service is reliable for you. If that as answer is no, then of course it is not reliable for you. The service level objective is basically you set up a service level objective. Now everybody aspire to be at 100% availability of a service, but imagine the cost that is needed to build those systems, build those highly resilient systems, right? Multi-million dollars. But eventually the difference between, let's say, 99.9999%, which means 5 nines after a dot, with 100% is less, and which means that you can only afford, let's say, 36 minutes of downtime, because 0.00001% eventually means 36 minutes of downtime in a specified duration is what you can afford, right? So monitoring that downtime, right, and taking an accountability that I only have 36 minutes would at least help you to do a couple of things. A, you can be very certain that what are the specific launches which can cause a system to go down, and hence if you have a budget available for you to afford that downtime in a specific period, is while you would approve that change to implement, or you would not, right? So that is where this concept of error budget came into the picture. So you always don't define the change, or rather the launch of a feature or launch of a product on the basis that whether a change team has really approved it, but you define it whether you really have a budget for it. So if at all, let's say you just have 60 minutes of downtime which you can afford, and you've already exhausted 48 minutes, and this new feature will take 5 more minutes of downtime if at all, then you would not really wanted to hit on SLO and SLI, but would convince management, let's see, I'm already exhausted, and hence I have a very clear business case that this should be launched at this time. So you can imagine, right, how effectively it is helping you to decide what can you do, and then kind of bringing in more accountability at your end to take care of that, right? The last part is basically, as we talked about, that SRE team focuses on both the things. So I'm not sure if toil is a very familiar word, but toil is basically used for any kind of operational issues or hiccups that we see while the team is working on, right? So it can be in the form of incidents, it can be in the form of service requests, and so on and so forth. So it is very, very important that this SRE team have to block their 50% of time for managing the tickets, which essentially means that if at all there is, let's say, a major incident, maybe 2 or 3 major incidents, then their 50% of time, meaning that they might handle just one major incident at that point of time, and might not be more. For others, they would either use the existing support team or not, because this was the entire premises on why this setup was being built in that manner, and there are advantages of how why it is important to create that balance out. And then the 50% time is focused on how they develop new features. And now if you look at this, there are also other ways to handle it. It should not be like that the person would be very time pressed, right? He would have a lot of responsibilities. How would he manage the things? So the SRE mindset, which is an engineering mindset, if they are actually working on the tickets, then they would really think about how, for example, if they are doing or working on, identifying a root cause of one of the major incident or a P1 ticket that has happened, lot of analysis that they would need, lot of things would get really automated, right? That's one. B, they would also look out for repeatability into the current structure or current support team, and then look out for identifying repeatable activities and look out for automating them, right? They might do that by themselves by using the scripts, in Python scripts, or maybe, Windows and Linux scripts, or maybe by using of RPA, or any other orchestration tool, or, probably, delegate it if they are, then the volume is pretty high to some of these automation experts. Development focus is important because, as you would know, right, there's this cutthroat competition into the world. So if your product does not really have that feature which an user is aspiring for, then there are bigger chances that you would be behind the competition, and hence you might not be able to attract those many numbers of users as much possible. And this would very well also reduce your time to market, right? So you can be a market leader if you are able to capture the right requirement from the user, which is a different discipline altogether, but then the team who would on the background develop these applications is where the SRE team can fundamentally help, and then they can take a conscious call based on the error budget that they are left with, that these features on when they can be logged. Now, if you see 1, 2, 3, and 4, they would eventually help to actually make the users more happy, and that was the reason of putting this picture onto the left side, to make sure that this whole focus is not to make the engineers happy. The whole focus is basically to make the users happy. Now, while we are talking about, right, these capabilities, but how would you make sure, right? Now we are basically clicking on the how part. How are we bringing these things into practice? So one thing we talked about is automated, and let me start by double clicking more on automated so that we understand that. So the focus is basically to build resilient systems, which means that the systems are mostly available. The automated failure of the systems happens, and then that can be either on the cloud or on your on-prem solution. But that is the whole premise, right? How do you ensure that your systems are available, and those 99.59% of availability that you are creating, how you can bring those technologies into that? The intelligent way of identifying how can you monitor, right? So typically, most of the times, if you are able to capture the issues that a user would face in the form of an event from a monitoring system, then that's a bigger win, right? So then how do you think that expanding your monitoring system to include a lot of such issues and monitoring them, and then basically reporting them as an event rather than a user incident, is a better way to handle it? And because if you are getting an event from your monitoring system out of any issue that the user is facing, as an example, right, your application, for example, is being utilized, and then we monitor availability of an application and infrastructure, and we monitor the performance. So those specific parameters that you are actually selecting for monitoring them is important, because if you have really got an event which got generated from your monitoring system, then the opportunities of automating them are fairly high, rather than automating a user ticket, because that is a bit complex, and you might need to use AI ML complex algorithm to first of all identify what is the real issue and then automate it. The second part, which is continuous everything, and we all know, right, a lot of you would be coming from the DevOps world, that how do you ensure that maybe your continuous integration, while you're committing, it goes to your main branch and then it works, and how would you continuous deploy? How do you continue to optimize? The one thing which is also very important is continuous knowledge framework. Gone were the days when you can be static with your knowledge. Now the world is moving so fast, right? Every other day you see a new term coming into the market in terms of technology. So how do you create those systems where the people are familiar with everything new, and not only with the familiarity, but how are they kind of equipped with the right set of knowledge to apply it into their current ways, is important for this SRE building capabilities. Platforms and architectures. So typically, the earlier set of architectures that was being followed across applications, that the systems were very discrete. Now the focus is more about bringing in more platforms, And the platform basically is something that is useful because most of the things that you would need, you don't have to don't need to use discrete systems and then maybe combine them, but typically using platforms and modular architecture, for example, microservices, is the important part, is important building block for you to meet the SRE objective. Elastic infrastructure, which means that, how quickly can you scale, right? If you could recall the system admin role that we talked about, one of the bottlenecks that they had to face was that the procurement time was really high. Now, given the fact that you have hyper converged infrastructure, you can always create, VMs by a click of a button, right, over the cloud or on-prem, right? So that way, these are, I would say 4 important building blocks, but they are supported by enablers. So you need to have a design thinking mindset. And what I meant by design thinking mindset is, how do you prototype what exactly your client is looking for, or maybe, your team is looking for, and then creating your human-centered method, doing a lot of experimentation, and then identifying what is really working well and what you need to change on is very important. A lot of this also comes from doing a lot of collaboration within the team, right? The other part is lean and agile. I mean, what I've seen a lot of times that most of our processes are being made when the team is being formed, but then an opportunity to relook at it, even though the changes in the technologies have happened, is very rare, right? And hence the lean and agile principles, which have came from the manufacturing world, of course, is something that kind of ensures that we needed to focus on rethinking about how can I make my process more lean, right? So I recall I was speaking to one of my client, right? And then their provisioning system at this point of time also takes almost 8 to 10 days. And when I found, right, then there is multiple, movement across the same team. They will do something and then they will go and take the approval. So think about what would be the best way to create systems, which is basically doing what it has to do, not it's always good to do, right? And then the last but not the least, the overall quality part, right? How do you ensure that every product, every service or component of your entire product is basically, giving the right amount of quality, so that if all modular parts are having quality parameters, then so does your product. So this essence is basically the background of how do you ensure that an SRE capability can be built up, which would be the real task, right? Or which would be the real capability building part. Now, I will kind of move ahead with an application of SRE, and the application that I've chosen is a very different application. I mean, it is not the application as in the application. It is basically how are we applying the principle of SRE. So let me, unveil it. So as we all know, right, we are in COVID times, and hence, a lot of us, maybe all of us, are operating from home. Imagine the days when you were at office, connecting back to your team, which are remotely located, was a couple of times possible over a video service, right? And how a video service typically works, that the video service is basically connected at the back end to a network component. And this network service is, of course, being provided by any of your internet service provider or telcos, and hence the availability of the video system was typically relying on your network performance, your network devices, and also your video devices and the video performance. So the case study was basically of one of the client, right, who had their global video service. The status was basically that the SLAs of all the 4 components which actually will make a video service available was high. Network availability was all the time high. Video device availability was all the time high. There were no network latency found. It was all going great. And the endpoint, which was the video, video device at your office or maybe at the client office, which was also working very, very well. But when we went ahead and, kind of took a confirmation, or rather took a CSAT, the customer satisfaction survey, we have identified that the customer satisfaction from the video service was all the time low. And this was something which was not just a one time view, but it was like kind of going on for, every quarter we used to conduct that assessment. And for continuous 1 year, we saw that our availabilities was all the time high, but the CSAT was all the time low. So now imagine that if the CSAT is low, will the service be reliable? I mean, imagine that this is a contract of, let's say, a service, an SI or maybe an IT service provider. So then can he really go with that same faith and ask from the client to renew that service? I'm sure a lot of you will answer this as no, right? Because if the service is not reliable, then of course, forget about the SLAs. It is not meeting the objective of that service for the reason why it was being hosted. So the first thing that we did was we have first of all accepted that this is a problem. That is the first step, right? If you don't accept it is a problem and you continue to argue that, no, we are really great and, my systems cannot be wrong, we are using the most updated technologies, then believe me, we are gone, right? So what we did was identified that yes, there is a problem, and we tried to change the things further. So the first thing that we did, which I would say most of you would always aim for, is try to look at the current team, right? And try to look at what exactly they are doing right now. So what we identified that most of the focus was typically in the same way like we talked about the system admin. So the focus was typically on doing the ticketing management and the development that were happening on the video services layer. They were both disconnected entity and not talking too much to each other, and hence these are all disjoint systems. And more often than not, the feature upgrades on the video services were very rare because of the same fact that people were pushing too much changes because of the fact that they were thinking that they will get the run team will get a lot of tickets. So what we did was we first of all made one team, and that team was again looking at the SRE principles, had a 50% responsibility of managing the ticket and 50% responsibility of managing the development, right? Of course, there was a development team which was there for, taking care of any, additional development effort that will come up, which this SRE team will not take care of. So the key focus basically, was for them is making sure that the system is available, which they were any which way is doing. Toil management. So they have to ensure that the 50% of the time was basically focused on managing the tickets. They had created very, very clear SLOs and SLIs, and I'll talk about it in a minute, that what does it mean. They were having a controlled change management because they know now that with their current availability, what is the downtime that they can afford. They had a couple of automation experts also into the team, or a couple of people who are cross-skilled into automation to automate the things which were more repeatable. And they had tools to basically predict, let's say, the network capacity needed to run a network, to run the current usage of bandwidth into a video service, and identify that maybe 6 months down the line, they wanted to upgrade it 2x time because the video traffic is growing more. So that level of visibility or basically that level of capability we have planned to kind of create into that team. The other part was that because their 50% focus was on the development team and development effort, and 50% was onto the support, then if they were used to get any additional load on the development, then there was a team which we have designated for a few days who will take up that effort so that they can really balance it out. And then the error budget, right, which is very important, right? So they would be aware about the error budget, and hence they can take the accountability. So out of those two responsibilities, which was typically around maintaining the availability of the system and the development, we have first of all established the right set of rules, the right set of areas which a team needs to do or needs to manage as they proceed further. And the objective was, of course, focusing on how would an end user see a video services reliability. Apart from that, right, we have also conducted a lot of interviews from the client to identify what would they call as a service reliability. So, and then looking into the ticket data, we identified these are the following trends. And this is also the aspirations from the user, that the VC device was available for 99% of the time, but they said, see, If it is available for 95% of the time, it is still okay, right? So that way we could really save some time here. What we could see was that there was a video lag, right? So somebody who is joined the video call, they see that 2% of the time they could not really see the current video, right? The video that was appearing into their video system was actually lagging, let's say 30 seconds behind and all that, right? So a lot of times we kind of hear that even when you are on calls. There was also an audible lag. Somebody has spoken right now, and then it is heard after 30 seconds or something like that. The overall drops that were there from a video, this was basically the performance parameter, should be less than 1% of the overall time in VC. So that's where they have established the service level objectives now, right? That now, because of ensuring that we have to take care of these lag things, we have to ensure that the video drop can only be 1% of the overall time. 95% of the time, the VC call should be received within 30 seconds. So what used to happen? You used to call it from here, and there, for example, if the person has not been there to attempt that call or attend that call, then possibly the call get disconnected. It might be because of a delay into the system, and hence the other person have not really got that request. So an auto login and auto acceptance of a call was one feature which the clients were really taking care of it. The other couple of things which you have also realized, that since these video systems were not very regularly used, so we also don't kind of test it more often, so that at the time when somebody comes and start using it, they found the systems more workable. So what we have realized, that all these service level objectives which were beyond availability were the ones which could eventually help us in adding few monitoring parameters, which would eventually help us in adding more features, which would eventually help us in ensuring, the big win is that the users would be more happy with the video services. So as a matter of that, what we kind of did was, we identified what we need to do. So we thought that since the video service is going to be available for 95% of the time, so apart from the device level availability, we have also started monitoring the log level availability, because normally how a device availability works, your monitoring system will keep on, let's say, sending a hello message to your device, and if at all it gets a hello message back, then that means it is available. But then device level intricacies are very important, and log analytics is one thing which is being done nowadays, is something which we have developed, and a self-healing capability. So if we identify a trend, then that does not mean we'll just end up creating a ticket. No, we will identify what has to be done to troubleshoot and fix it. So a log gets detected which points out to an error, and then that gets self-remediated, is a solution to this, which is by virtue of the automation. The second, the video lag 2% overall time, right? So there was no system into the monitoring, the current monitoring setup that they had, where they can identify the lag. You can identify a network lag, but you cannot really identify a video lag. So then we did some of the research there, and we identified that there are little correlation within the log that you can identify, and then you correlate, and that's where you will be able to identify whether it is really a lag or not. And that identification and auto self-healing of that video lag is what we were able to take care of it. Imagine the support team earlier, they did not had a clue that this was a problem, and they did not even think about monitoring it earlier. The other was same related to the audio lag, where they have identified that the audio lag has to be less than 1%, and hence we did the same thing by monitoring the logs there and ensured. So all this would have really not been possible without bringing in that engineering mindset, because the people who are coming from the support and development background, they would know that how difficult it is to actually do an audit on the log and then to derive out insights from them. The other was basically how the same thing again, video drops less than 1%, and then we have discovered that for the last one, that there were a couple of features which were available within the system, within the video system, and eventually it has to get enabled by bringing in more, let's say, customization into the current system. So we need to talk to the vendor and get them enabled. But eventually, as a result of this, all those 5 wish lists which would make a service more reliable, after an exhaustive exercise of 3 months, we were able to crack how would you do it, right? And with the same team, we have not hired any new people. So it was having some 7 people into the team, and out of the 7 people, we have designated 4 people as an SRE people who are kind of working on this one. Now, having established the ground rule, having identified how would you, solve that problem, you need to sustain it. And that sustainability came by monitoring it. So monitoring as in identifying the reliability of the device. And as we said, right, we have already identified the benchmark of what would you call it as the reliability and availability for the use. So you would monitor the reliability, and then there are these speedometers that we have created to kind of show that how it looks like. And you would also identify the error budget and also keep your client informed about it. Let's see, I cannot really do this change feature that you are asking me to do right now because I'm already exhausted with my error budget. So if at all he approves, then he really signs off that there is a breach of error budget that you're doing. And we monitored it across all those things, right? We monitored it for availability, for video lag, and for video drops. At the end of this, I have not captured it because it is really client sensitive information. The 95%, 99% of the availability of the system was of no use, but 95% of the availability of the system was of much more use because now we are digging it more deeper into it. The response time of the tickets, which was eventually half an hour earlier, became 5 minutes because we have more automated systems. The resolution time of the ticket, which was on an average 4 hours, became 2 hours. That means we have gained 50% of the time here. The team strength, which was 7 people, now were just 5 people because there were 4 people who were basically the SRE team, but then we were able to reduce to because most of the things that they were doing were automated. But the story did not finish there. We were able to bring in great features into their current video system. In fact, we have enabled that how they can use Jabra and how can they basically log in from their mobile device to log into any of their video calls and have the same feature which they could experience by going in front of an endpoint. So the satisfaction, which was really going down of a user, have raised up. The users were very happy because we could bring in more features. The reaction time, the resolution time has all increased up. So this was the story that with that I would like to kind of end up this discussion